What is up, guys? We are going to look at this farmer problem, uh, and we are going to give him a nice little fenced off area for his pigs and chickens and hens and whatever that he wants to, or she wants to create, right? So here we go. So this is the scenario. Farmer has this rectangular area. So a rectangular area, let's say this is the rectangular area, and then he wants to divide it into four pens of equal fence, oh no, four pens of equal size with fencing parallel to one side of the rectangle. So that means something like this. That is three. Whoops. Ugh. Let me fix that. That's gonna bother me. So one, two, three strips, or three additional pieces of fencing so that there's four open pens. And it's parallel to one side of the rectangle. Cool. What is the least amount? Ooh, so there it is. There's that key word that I told you guys, right? We got to look out for these keywords. So least amount. So we're not maximizing, we're actually minimizing, right? We want to minimize the amount of fencing used because we don't want to spend more than we need to for this fencing. And then what's the least amount of fencing he must use in order to enclose a total of 160 square meters. So probably at this point in the video, maybe pause it and think like, what two formulas do I need, or which formulas do I need? Is it two formulas? Is it three? Is it four? Let me see what the scenario is asking for. There's words like area, and it's a rectangular, fenced off type of structure, and we're dealing with fencing. Fencing is our material. So try and pause the video and figure it out. Once you did that, so here we go. If we're talking about square meters, we're talking about an area, aren't we? Where I'll just label, I don't know, this side length and this whole side width. So like I said in class, the derivation of these formulas is the hardest part of these problems, right? So area is going to be length times width, okay? And then another formula that we can use, or the other formula we're going to use is, well, the one that deals with the minimizing part. We need to minimize the amount of fencing. Well, what determines the amount of fencing, right? It's this plus this plus this, plus hopefully you guys can see what I'm doing here, right? I'm going over the perimeter, but then I have to include this piece, and this piece, right? So if I want to put this all in terms of the same context of the same context is the same, oh my gosh, I can't talk right now, in terms of the same variables, right? Essentially what we're doing is we're doing perimeter plus 3L, right? We're doing the perimeter of the whole thing plus 3 times 3 additional middle pieces that I'm going to highlight here in red, let's say. So it's like these 3 red pieces plus the perimeter. Hopefully you guys can see that, right? So if I were to just rewrite this guy now, this becomes, what is this? 2L plus 2W plus 3L, or 5L plus 2W. And this is going to be the thing I want to minimize. I hope that makes sense, right? So from here, what we're going to do is see if we can get this all in terms of one variable, right? Because we don't like functions in terms of 2 variables. It's hard to derive with respect to, one variable. We don't know how to derive with respect to 2 variables. So what we're going to do is, since we're trying to minimize this second one right here, right? Since we're trying to minimize that, well, we have to use this guy to help us rewrite one of the variables, right? Do we know what the total area is going to be? Yeah, they say it in the problem, 160 square meters. So if I write 160 equals L times W, that means I can solve for one of the variables, L or W. Doesn't matter, dealer's choice. And then I'm going to derive the this function down here with respect to one of those variables. So why don't I do this? I'm going to just solve for, I don't know, I'm feeling crazy. Let's solve for W. And you get 160 over L. So I'm going to plug into here, and I'm going to get an area. Nope, not an area. We're not talking about area. I don't know what to call this function. Maybe you just call it P. for sort of perimeter, but it's not really perimeter, you know what I mean? But I'll call it P of L, since my function now is going to be in terms of L. So it should be 5L plus 2 times W, but it's not W anymore. It's 320 over L, because I plug in W, right? And look, I have a function here that I'm trying to minimize. So let's see it. Let's see the derivative of P, and I get 5 plus, what is this going to be? So L to the negative 1. So that's going to be, it's going to be minus 320 L to the negative 2. Right? And since we were trying to minimize, or since we're trying to optimize, right, we're going to set this whole thing equal to 0 and see what's going on. Right? So this becomes, I hope I don't run out of room here. I didn't plan this out well. 320 L to negative 2. I add that over, so it's 320, and I'm going to multiply both sides by L squared. And then you divide by 5. What is that? That's like 64. Oh, look at that. It's a nice number. Love it. This becomes plus or minus 8. But if you guys remember in class, right, I said to consider the domain. And this one's kind of easy, right? Like, you can't have a negative length. It's not going to work. So it looks like 8 is our critical point. Last thing we want to do is just confirm that 8 is indeed a minimum, right? Because we want the least amount. So let's plug in a number to the left of 8. I don't know, like 3. I don't know. Let's plug in 3. And do we get a negative... Wait. Yeah, do we get a negative value, right? If I plug in... well, I can't plug in 0, right? Because L is on the bottom. So let's just plug in 1 to make it easier. And you get 5 plus negative 320. Yeah, that is definitely negative. And then if I plug in a number greater than 8, like 10, P prime of 10, you get, I hope you get something positive, right? You get like 320 over 100, negative 320 over 100 plus 5. I'm sorry for running in a room here. And that is going to be actually positive. So yeah, this confirms it. The measurement of 8 meters is a minimum. And that's it. Oh, wait, no, we're not done yet. Oh, I always do this. Least amount of fencing. That's what we're trying to figure out, right? So what are we going to do with this 8? We're going to plug this into our function. Actually, no, we can plug it into the P function, and that'll tell us the amount of fencing that we're going to need. So I'm out of room. Let me just do this in like blue. Oh, shoot, class is about to start. P of... what were we doing? 8 equals 5 minus... No, I'm sorry. 5 times 8 plus 320 over 8. I was about to plug it into the derivative by mistake. This equals 40 plus... what's 32 divided by 8? That's 4, right? So it's another 40. Look at that. It's 80 meters. So this means, in the context of the problem, Farmer Joe or Farmer Jane or whatever, the farmer person, is going to need 80 meters at most to create this pen that he wants to create. Okay? All right? Always understand the context of your answer with respect to your problem. All right? All right. I'll see you guys later.